Now the third point that we're going to analyze in this particular titration is what is the pH after the addition of 12.5 milliliters of sodium hydroxide. And again, here's our equilibrium. We have acetic acid and sodium hydroxide giving us sodium acetate plus water. So we're going to set up our initial, the amount that we add, our neutralization, and our endpoint here. Again, we're starting with 2.5 millimoles of acetic acid. If we have 12.5 milliliters of sodium hydroxide, remember the concentration here is 0.1 molar. So 0.1 molar times 12.5 milliliters is going to give us 1.25 millimoles, and that's how much sodium hydroxide we're adding. In the neutralization step, we have less amount of sodium hydroxide, so we're going to use all of that up, which means we have to use up 1.25 millimoles of acetic acid. So at the end, we have 1.25 millimoles of acetic acid, 0 moles of sodium hydroxide, and then we're going to add 1.25 millimoles of salt. So after all of this reaction is complete, we have 1.25 millimoles of acetic acid and 1.25 millimoles of sodium acetate. So this actually becomes kind of a special point in the progress of this particular reaction, because here we have the log of A minus over HA, and this is going to be 1.25 millimoles divided by 37.5 milliliters, and 1.25 millimoles divided by 37.5 milliliters. So again, the volumes cancel out, and the pH is actually at this point going to be equal to the pKa. And remember, the Ka is 1.8 times 10 to the minus 5, and the pKa is then going to be 4.74. And this is a special point in our equilibrium, or sorry, our titration curve, where the pH is going to be equal to the pKa. So in the next video, we'll look at the particular pH at the end point of this particular titration.